All right, I guess we're ready. If you want to use a clicker, this one works. Okay. You're mic'd up. Yes.
So you want to?
And so we're all mic'd up. Here, here's your mic. You want to use one of these, or you want to use a handheld?
No.
Here. Is it on? There's a switch on top. You can turn on when you're ready. It's off. It's good. Use what?
You use this.
Yeah, but this is off.
I'm not. Am I mic'd up? I don't know. Everyone take their seats, please. Can you hear me in back? Ali, can you hear me? No. Good started? Most of them should be, yeah, the ones that we have any control over.
Okay.
Well,
I mean, like some of them are really good as far as the storage.
Yeah, we'll get the slides on.
Okay, can we get started? I want to make a couple of quick announcements. One is that all the slides will be available, so you don't have to take notes, hopefully very soon, in a couple of days. The second announcement is, please don't stand in the back rows because it is difficult for people to get in. Also, difficult for people to see. So if you can come and take your seats, that will be good. Okay. Let me quickly introduce Larry Peterson. Larry is our chief architect at Open Networking Lab. He is also the chief architect of CORD. Larry has had a very distinguished career. He's a member of National Academy. He's a ACM IEEE fellow. He was the recipient of SIGCOMM award, and the list goes on. He has been in research. He has been an entrepreneur, and we are very lucky that he's now at ON.Lab as well. So,
Thanks. So, thank you. Is this mic working? Okay, thanks. It didn't seem like it. So we're going to transition. We had some great talks this morning explaining why we're all here and why CORD is important and why it's getting traction and why there's so many of you in the room. This afternoon, we're going to go down to the nuts and bolts. We're going to break into community subgroups. We're going to talk about the implementation. We're transitioning right now through the technical ideas that hold CORD together as a project. There's going to be a couple of talks. Saurabh and I are going to tag team and look at the architecture and the technical aspects of CORD. There's a lot of information on the website I'll point to at the end, but I am often asked the question because it's kind of a tricky answer. What is CORD? And we've purposely, it's a really good acronym, but we've purposely made it a little ambiguous because it's many things at the same time. It is a vision, and that vision is this goal that the open source community is going to be working towards. So a lot of people are buying into the vision. It is also an architecture. That is a set of interfaces, a set of abstractions, a block diagram of all the components. And last but not least, it is a reference implementation. And that means we've made some technology design choices. We've put enough pieces together to build what we think is a fairly complete system that you could go to field trial with. Now, it is also a process. And this is near the beginning. This is nowhere near the end. It just happens to be a more open transition for us. So I wanted just to say a couple words about that process. So in terms of the vision, we started with what's a pretty sound business case, right? It makes sense to carriers and service providers to go in this direction. but we have to reduce that to a set of design requirements. And so we're in the process of doing that. In terms of the architecture, we started with an organizing principle. Everything is a service. It was a way to think about the problem that kind of brought all this disparate pieces together in a common kind of way. And so that's where we started, but then we iterate and refine, and that architecture started to take shape in the form of abstractions and interfaces. And finally, in terms of the reference implementation, we did make some technology choices, and we're often asked, well, why couldn't it be this? And the answer is it could have been, but we had to make some technology choices, and where we are now is at the point that we can start being more inclusive with some of those choices. It still needs to be consistent with the architecture, and the architecture needs to be consistent with design requirements, but that is the iterative process we're now engaged in. So for the few minutes I'm up here, I'm going to talk just a tiny bit about the vision, because you've already seen that. I'm going to talk just a tiny bit about the reference implementation, because we're going to spend the afternoon on that. Spend most of my time in the middle on the architecture. All right, so in terms of the vision, this is a really nice summary. It's the economies of a data center and the agility of a cloud provider. But let me sharpen your focus on this in just a couple of ways. First of all, we tend to think of access and the central office not as a different thing. It is just one piece of the larger service spectrum. So we want to think about access as a service. So when you think about going to Google or Amazon or Microsoft's cloud portals, you see a set of services. Imagine if one of them was access, and that is in fact how you opted into the cloud. So we want to think access as a service, but we don't want to stop there. We want to think everything from there all the way to what you would otherwise think of as a conventional cloud service. So it's that entire spectrum we're trying to bring under one umbrella. The second thing is there are a lot of legacy equipment out there in these central offices, and some of them can be picked up and put into virtual machines and dropped into commodity servers. That's the bundled legacy. We want to do that, and we want to disaggregate those services and turn them into smaller building blocks. And so blowing up a B&G is actually something we're going to try to do. All right, so that's just a slight focusing on the vision part of the equation. So let's go to the architecture. So of course, the high-level pictures, we want to transform that proprietary 300 different heterogeneous devices central office that grew over the last 40 years into something that's built out of commodity hardware and open source software. Well, what is that transition? And the first part of that transition, as I indicated before, is an organizing principle. And the organizing principle we brought to bear in terms of CORD was that we wanted to treat everything as a service. And by service, when you hear me say service, think cloud service. Don't think the traditional customer service that you turn on and off at your provider. Think of it in terms of cloud services. Well, that is in fact the intersection of NFV, SDN, and cloud. And so a lot of times in this space we hear, well, we understand SDN and NFV have to come together, but you have to bring them together in the context of best practices of scalable elastic cloud services. And so that is, again, the organizing principle. But the key is that you get more out of that if you do it as a combination than if you just took each one of those circles by itself. So just to draw attention to what the value is when you approach the problem with this particular organizing principle, the cloud allows us to extend microservice architecture, which people are buying into as a good design, all the way to the access network. So access is not other, access is one of the microservices. In terms of SDN, a lot of people think about SDN as a way to plumb together the virtual network functions, but we're actually also using SDN as a way to generate new virtual functions. So our VNFs are both in the control plane and the data plane, and it's treating them both as services that is the unifying aspect. And then finally, in terms of NFV, we aren't stopping with NFV equals bundle legacy function that used to be tin wrapped and making it a virtual machine. We're doing disaggregation, and that's a critical aspect. So those are the advantages that you get when you bring these together. All right, architecture can be described in terms of the hardware. Again, this is a picture you've seen before, and important aspects of that of the leaf spine fabric, and the fact that we have access devices that are connecting it to the home. In this particular case, I'm going to be using examples from the residential version of CORD because that's where we've made the most progress. But over here, we've got racks of 48-port 1U boxes that connect you to GPON out to the homes. And that's just one aspect of the entire commodity multi-rack cloud that you have. So Saurabh will talk more about the switching fabric and all the software that manages that. I'm going to move on to the other parts of the system. That's the hardware architecture in a picture. Here's the software architecture in a picture. And it is abstract, and it is only a picture, but it has a couple of important messages. The first important message is that it is a configurable system. You configure in the set of services into a service graph. And there's an example service graph that includes some of the access services that I'll be talking about in more detail in a second. It also is very recursive. We understand the power of one of the powers of SDN is that we've separated the data plane and the control plane, and that means we have a controller that's responsible for controlling the data plane in the network. Think of the same thing applying to services. Individual services have a control plane, a controller, and a data plane where the service does its work, which in turn probably depends upon the network data plane. So we're applying that principle. We're not just applying it to individual services, we're applying it to CORD as a whole. So CORD as a whole has a controller. And you'll see a little color coding here that I'm going to try to stick to, which is if it's red, it probably ran in the data plane in a virtual machine or container. If it was blue, it was running in the control plane on ONOS. And if it's purple, that's the blending of blue and red. That is the unifying aspect of a service. All right, so what are those? What's Volt, what's VSG, what's vRouter? Well, basically, those are the output of a disaggregation process that we underwent. So this is a legacy depiction of a legacy central office. There's a CPE in the residence. We've got an OLT and a BNG, and you can read what the acronyms mean if you haven't seen them before. And so this is a process of disaggregation I'm just going to step through. Well, one aspect of disaggregation is you break the control and data plane, but that's just the first strategy you use. So you go to the CPE in the home, and you break out the data plane and the control plane. Well, what's in your control plane at home? It's some of the extra functions that you have subscribed to, firewall, parental control, whatever services like that got loaded onto your CPE. We're just going to move those back into the central office, and that's the VSG, Virtual Subscriber Gateway. It's actually just going to be a container running on behalf of each subscriber that connects into the central office. We take the OLT, and we're going to do the same control data plane split. The control plane is going to be the one the data plane is going to be the one merchant silicon device that gets plugged into the racks in the central office. And the control plane is Volt, Virtual OLT. And it's going to be an ONOS app. Then we're going to go to the BNG, and we're going to do the same thing. We're going to take its control plane off, and that's vRouter, Virtual Router. And the data plane is going to be left behind. I'll show you what that turned into in a second. But the BNG was actually a very, very large bundle of functionality that got split up and put into different pieces. The IP routing piece is Virtual Router, but the per subscriber functions got moved into VSG. And so anything that you would have turned on a per subscriber basis now comes back into the container running on each subscriber's behalf. And finally, authentication, which didn't happen until you hit the BNG, has to happen much earlier because I'm giving you access to a container. And so authentication and access control moves all the way back to Volt. So in the control plane, when you power on your home router the first time, authentication is triggered, validates you as a user, a container is spun up for you, and then you're off and running. Finally, the data plane of the BNG and the switch, the Ethernet aggregator is in fact the switching fabric. So if you go back to the previous picture where I showed you this leaf spine switching fabric, which Saurabh's going to tell you more about, that is that is what is left over in terms of the BNG. So the BNG does not exist in this architecture. And as Al was mentioning this morning, we can now reuse these other pieces in different ways. So vRouter is going to be usable by a lot of different configurations of CORD. All right, so if you kind of then could look down on the end-to-end path, we basically have two control apps controlling virtual networks. We have the containers being spun up in the virtual VSG, and from home you're coming in over a virtual network we call LAN-side virtual network, and on the outside your containers connected to the internet through a WAN-side network. Those are both implemented by the hardware that's in the pod. So it's your home CPE connected into the ONU, to the OLT device that's sitting in the central office, connects you into your container, which then over the switching fabric, under the control of the virtual router, gets you out to the internet. And I'm showing a third-party service sitting there as well. It's a virtual CDN, also using virtual router to get to the internet because it has to go out for to fill cache misses. So that is, in fact, what this is, but what's under the covers is it's basically a set of models. Everything in CORD is model-based. We define models, or I could have used the word abstraction. They're just nested. And to understand how CORD works and how all these parts are working in harmony, you have to kind of look down the nesting of the abstractions, which I'm just going to very briefly put up. You start with instances. They can be containers of VMs. You bundle a set of them together and connect them by a virtual network. We call that a slice. That's a CORD-wide resource container. You add a controller to a slice and you get a service. And you define dependencies between services and you get a service graph. You anchor service graphs at tenants, which correspond, for example, to subscribers. So those are just objects in a data model. And it's by how those objects are defined that you get the behaviors of the previous picture with everything actually being connected end to end. There is no oracle that says, these are the paths to the system. It is completely decomposed into these abstractions being applied in a nested way. Just a real quick look to give you a sense that these services are implemented in different ways. And the power of the service abstraction is it makes them all look alike for the sake of service composition. So if you drill down on the data plane services, sometimes they run in containers, one container per user. Sometimes they're horizontally scaled like a scalable database would be scaled. So the mapping between the service abstractions definition of an instance and the compute instance, there's different mappings that are possible. And if it's blue, it's basically a control app running on top of ONOS. ONOS scales horizontally across the set of compute instances. And it takes its apps along for free. They get to scale horizontally as well. So that's a set of abstractions or models in a data model. But we then generate interfaces that are northbound on top of that. And so I just wanted to highlight some of those interfaces. And I could have just had a list of interfaces, but I want to group them in two different time periods. There is a design time configuration interface. This is actually motivated by eComp's way of describing the world. It was very good when it matched naturally, so we've adopted it. We've got design time configuration interface. That's when you onboard a service. As an operator, that's when you say, you know, I would like to buy that service from that service vendor, license it, whatever, so that I can offer it to my customers. There is an onboarding process. And then there's a control time interface. Once you've built a service graph, consumers or subscribers are connecting and disconnecting and spinning up VMs and spinning up containers and so on. And when they do that, there's a control interface so that from home you can control whether you get parental control or not. So if I look at that in terms of a picture, that is the CORD controller. There is a REST API that's generated out of the data model, northbound facing. You can put whatever OSS, BSS system you want on top of it. You integrate it into eComp, you integrate it into whatever. And then that interface controls everything inside of CORD. It's RESTful, but there's also a Tosca version of it. We tend to use the Tosca version for configuration time and the REST API for the runtime control, but you could do that either way. So if you crack open that controller and look inside, you see two fundamental pieces. You see a data model from which the REST API is generated, and you see what we call a synchronizer, which is basically the activator that watches for changes in the data model and then does the right thing on the back-end system. Makes heavy use of Ansible, but it also has to look across models because you're doing service composition. A lot of pieces below you might get touched. They need to be touched in a consistent way. That's the job of the synchronizer. And so onboarding basically means you bring to me a model to stick in the data model to extend it and a corresponding synchronizer module. It's a framework and you plug it in and it gets called at the right times. In terms of the runtime control, again, there are different forms of this interface, but there's a REST interface there. And so I'm just showing you an example of a call on the REST interface to read the information associated with subscriber 1. And everything over on the left-hand side are the features that you could do turn off and on or ramp up or ramp down. So I could do a put call and I could change your status, for example, to account delinquent, or I could change your uplink or downlink speed. The items on the right-hand side are basically information about what's going on under the cover so that an operator portal, customer care portal could see, well, here's your container, what's going on. All right, so data model, synchronizer, APIs. And that is the GCORD controller. And then, of course, you got to plug in your specific services. So moving from the architecture down to the reference implementation now, just again for a couple slides, we've got a lot coming this afternoon on that. Again, this GCORD pod is a notion that you can build out a partial rack, a full rack, a couple rack worth of hardware. And it is a pod in that you can drop it into some field trial or drop it into some lab. And you've already seen from Guru earlier, we tell you what the hardware is, we tell you what the software is, we give you an assembly instructions that both assemble the hardware and builds out the software. And you can configure it differently. So this isn't like push one button and it does everything. You got to say, I want the residential version, I want this version, I want that version. There are CAN versions. You can come in and define new configurations as well. And that, again, there are partners like Sienna and Radisys that are working to build turnkey versions of this. We're hoping that what you get out of the reference implementation off the open source will be close to turnkey, but of course you're going to want to configure it for your environment, and so there's still work to be done. Again, in the context of reference implementation, we've proposed a particular configuration of OCP hardware. In this particular pod configuration, we've got 4 OCP compute servers. We've got 6 switches, 2 leafs per virtual rack, and 2 spine switches, and some number of somebody's OLT devices in the residential case, but that's where you would plug in the access technology of choice. And again, taking a slightly deeper look at the software, these are the 3 big pieces of software. ONOS is, of course, hosting all of those control plane apps. OpenStack and Docker are hosting, in that sense, the various scalable data plane services. And XOS is the piece that treats both of them as though it turns both of them into services by generating the purple stuff that I showed you at the top before. So while it might have been Vault down below, that's an implementation. We think of that as access as a service when you get to the top. And there's an assembly process that goes on there. And if you combine that hardware with that software, you're now ready for a field trial. And so this is one that we have done. This was, if you were at ONS, you saw this one demoed there as well. So I want to finish up with just one last message. This is a slide that you saw from Guru earlier, and it's basically saying you can take this same hardware software platform and you can use it in different domains. I would like those lines to be fuzzier. I mean, the fact that we break them into domains is an artifact of market business units today, market segments today. That doesn't mean couldn't be a lot of blending between those lines as we go forward. And that is really what we're after in the end. And so one way to think about this is that GORD is, in fact, a platform. ONOS was a platform. GORD is now a platform as well. And so this is the service graph for the residential case. I've just slightly reorganized it because I'm going to want to extend it. Vault is a consumer of the VSG service, which is a tenant of the virtual router service, and so on. Well, I can also, one of the reasons it got broken that way is I could bring in different access technologies. So G.fast, 10G-PON, DOCSIS, that whole thing now is playable based upon the access technology that I happen to use. VSG stayed the same. vRouter stayed the same. That's the beauty of building something modular. Well, I can also bring in wireless access devices like a virtual BBU, and then I'm serving a different set of consumers, the mobile subscribers. They may have a little different something upstream from them instead of a virtual subscriber gateway. Yeah, maybe it's a little legacy. I'm kind of taking some liberties and pretending we've moved a little bit into the future with this picture, because that turns around and uses vRouter to get out to the internet. And if I happen to come in from the enterprise, same kind of picture, maybe I'm using 10G-PON now, and I can go out to the internet, or I can go out to a virtual carrier Ethernet. I could have actually connected the mobile subscribers to the virtual carrier Ethernet to get them across the metro area to some exit point to the internet on the other side. Right? vRouter technically could run on the other side of the metro area, and there could be one on behalf of the entire metro area. There are no limits to how you can reorganize these things once you bring them into modules. Okay, so in summary, again, going back to the three peer tenets of what we're doing, cloud, NFV, and SDN, CORD does provide the economies and agility, but it does that by fully exploiting the microservices architecture, including access as a service. It tries to exploit disaggregation, and we've given you an example of that with the virtual subscriber gateway, Volt, and vRouter. That idea still has to be applied in other domains, but it has been demonstrated there. And it fully exploits SDN, both in terms of the plumbing of everything else and as a source of innovative services itself. The controller is the glue that holds it together. You assemble services from parts, and once you've done that, you have an interface that now is the interface to the pod as a whole, an interface to all of those services. Finally, just a quick pointer to the information that's online in case you haven't found it yet. OpenCORD.org is the sort of the cover website, lots of good information there. But if you're really interested in getting under the covers to see what's going on, it's the wiki that you want to go to. And if you're going to build a pod, please start at this wiki and not anything else that's out there. Our biggest problem right now is old readmes from old places that people jump into because they did a Google search and it sent them over here. Come in through the wiki and you'll see directions on building a pod. Again, we're going to talk about that a little bit more this afternoon. Building a full hardware pod is still not a trivial task. There's a lot of moving parts there, but you can bring up a single node version, which is a good development environment to get started on. And everything about Linux Foundation governance and all of that is on that side as well. So I think I have time for a couple questions, and then we'll go on to the Surav's talk. Yep.
One of the challenges here is interop. The vendors that provide the OLT and ONU, they don't interop. So how are you planning to address that problem?
We're not planning to address that problem. That's the vendor's problem. No, we're providing a platform that different access technologies can be brought into. If you bring it into the picture that I showed and you make it interface upstream with virtual SG, VSG, and with virtual router, then at some level you have just made it interop. That's the strategy, is that these interfaces right now are the ones that we came up with on a first pass. That is what needs to be hardened and refined as 6 different vendors come in and we realize that that interface wasn't quite right. And like any device-specific interface, there's going to be the generic aspect of the interface, and there's probably still going to be device-specific, vendor-specific aspects to it. There's no magic in solving that problem, though. Other questions? Okay, thank you. And Surav, oh, there you are.